The car is king. In the last 30 years, the number of cars on the road has trebled, and more cars means more accidents. 20 million people around the world are injured in road accidents every year, and over 1 million people are killed. That's equivalent to the entire population of Barcelona. But amazingly, although the number of accidents is going up, the number of deaths is actually going down. In the past 30 years, they've reduced by half, thanks in large part to one ingenious device, the airbag. The idea of an airbag seems simple enough, but in fact it's an incredibly sophisticated mechanism. From the moment of collision, the airbag has only 50 thousandths of a second to inflate and stop the driver being hurled through the windscreen. That's a quarter of the time it takes for a hummingbird's wing to beat once. But that's not all. If it doesn't then deflate within just 0.2 of a second, the airbag itself might kill the driver. So how do you get an airbag to inflate at supersonic speed? How do you prevent a solid airbag from killing the person it's supposed to protect? And how do they know when to go off? How do they do it? Vårgårda in western Sweden is the home of Autoliv, the world's leader in airbag technology and production. It makes airbags for almost every car on the international market, 3.5 million of them each year. But the designers and manufacturers aren't the only heroes at Autoliv. Hidden away is a team of specialists without whose sacrifice airbag development would be impossible. Deep in the heart of the building, a dedicated band of operatives do their job without any thought for their own personal safety. Without moaning, this lot will take everything thrown at them. Ouch! It's a pity to treat them so roughly because these dummies are themselves massively complicated machines, costing a staggering $180,000 each. These things are like cyborgs. Inside them is a complex metabolism which mimics all the key functions and characteristics of the human body: skeleton, organs, nerves, even veins and arteries. And they're also crammed with thousands of sensors to record and relay exactly what happens to a human body in a serious car accident. It's even worse when you can see what's coming. Oh! Thanks to these dummies, Autoliv have designed a range of rapid inflation airbags that have reduced fatalities amongst seatbelt wearers by 25%. But how do these bags inflate at such terrific speed? The secret is to have a bomb in your car, more specifically, in your steering wheel. Airbags are essentially a combination of sensor, ignition system, explosive device, and nylon balloon. The bomb really is a bomb. The blast is achieved by a controlled ignition of high explosives which are packed in the form of pellets, and the force of the blast pushes air into the balloon at incredible speed. Different vehicles demand different airbags, and their design is improving all the time. For each new design, a 3D virtual model is produced, and from this, a prototype is created. The nylon balloon is made by a combination of precision laser cutting and machine stitching. Before the crash test dummies can be exposed to the airbag itself has to be tested. A steel weight is driven into the steering wheel to ensure the bag can repel the force of the average body at over 40 kilometers per hour. Once the test is completed, any faults are modified by design technicians. Lives depend on the design of these airbags, so every aspect is examined again and again and again. The problem they found here is that the airbag doesn't deflate quickly enough. In a crash, such a simple design fault could cause a driver's neck to snap like a dried-out breadstick. So a solution is found.
Okay, my proposal is that we increase the size of the ventilation holes by, I think, like 30%. Okay. What do you think about that?
Yeah, sounds good.
After modifications have been made, it's back to the stitching room to create the new design. Once this is complete, it's time for the final test to take place. At last, the crash test dummies are allowed out to play. But this is no Sunday afternoon drive in the country, as they're about to find out. They're lowered into position and their sensors are checked. Autoliv makes $320 million worth of airbags every year, and they can't afford for one to go wrong. In theory, this new design works, but will the airbags save a life in practice? It's a critical moment, and it's over in the blink of an eye.
3, 2, 1, 0.
Success. Our Terminator friend lives to fight another day, and the airbag moves on to the next stage of development. It's vital that the airbag doesn't go off randomly, or when a frustrated driver punches the steering wheel. The problem is to get it to fire at the right time. So how does an airbag know when to go off?
There is a sensor on the left side, here, 10 centimeter in, and another one here, and 10 centimeter in here.
In the event of a crash, these sensors relay information instantly to a central control box inside the car.
And then the signal goes from the box here up to the airbag, and you have a deployment. And all these things are happening in a fraction of a second.
But even when the sensors activate the airbag at the correct moment, there's another problem. The airbag is housed in plastic. The explosion could cause potentially lethal shards to be blown around the car, killing or maiming passengers and ripping the airbag itself. The ingenious solution is only visible at 1,000 frames per second. Each airbag compartment has a front section that is slightly weakened by a series of minute holes, too small to be seen. This weakened casing then ruptures during a collision, allowing the airbag to expand, but ensuring the plastic stays in place. At this speed, we can also see how the ventilation holes enable the airbag to deflate rapidly to save the driver from head and neck injuries. So, following extensive tests, the airbag can finally go into production on this assembly line. The finished airbags have the explosive device added. This is then bolted into place. The airbag is automatically folded before being fitted in its housing. This housing is then placed within the steering wheel compartment. And another airbag is ready to make another driver that much safer.
I'm very proud. I know that each day by working here, I save life out in the traffic. During 1 year, we probably save 15,000 lives. That's a good thing.
Finally, spare a thought for those selfless, smashed-up cyborgs. For them, every day is an accident waiting to happen.